Hi students, welcome to the next lecture of electronic measurements and instrumentation. My name is TSS Nagapavan Kumar. Today we will discuss the concept of function generators. Today we will see the concept of function generator. Alright. So coming to that, this is the basic block diagram of function generator. So coming to signal generators. Presently we are discussing the concept of signal generator. So the function generator is one of the device which is under the signal generators concept. Generally from the signal generator we will get three different types of functions. They are sinusoidal function, square function and triangular function. Here we will get three types of outputs. So three types of outputs we will get from this function generator block diagram. Let us see. In this block diagram, here we have three types of outputs. The first one square wave, second one triangular wave, and third one sinusoidal waveform. So three different types of outputs here we have: sinusoidal, square, triangular. Three types of outputs are available. And coming to that, any type of signal generator is consisting of two types of basic building blocks. The first one oscillator, second one attenuator. So here for generating a signal, here we have an oscillator. This is the setup of the oscillator concept. This is the setup of the oscillator concept. In this concept, alright, here we have the frequency control network. In this frequency control network, here we have the oscillator. At the input side, here we have oscillator. From that oscillator, we are getting the input signal. By using this frequency control network, which type of frequency we require, that we can allow into the block circuit diagram. In this block diagram, otherwise into that next blocks. So coming to here we have an external frequency control and here we have an internal frequency control. The external frequency control generally we are using an optional parameter. If you require, we can use this one, otherwise we can avoid this external frequency control. So the internal frequency control which will select the any one of the frequency of the input signal. So that input signal, that frequency value here we are finalizing. The frequency value here we are finalizing. That frequencies are fed back are going to be next upper constant current source and lower constant current source. Upper constant current source and lower constant current source. These upper and lower constant current sources outputs we are connecting to an integrator. These two outputs we are connecting to the integrator by using a switch. So this integrator output directly we are representing as the triangular wave output. So the integrator output we are representing as this is the output of the triangular waveform. That is, the integrator output is nothing but as triangular waveform. Yeah, that means we can say this is the triangular wave generator block, right? Next, if you want a square wave signal, then this triangular waveform we have to give to a voltage comparator circuit. This voltage comparator circuit will compare the input voltages and it will identify the positive level logic, low level logic. These two, based on these two level logics, it will generate a square wave. That square wave output we will get at the output of the amplifier. So this is a square wave output. Next, coming to that, the sinusoidal waveform. So from this integrator we are getting the triangular waveform. This triangular waveform we are giving to the sine wave shaper circuit, or we can call this is resistance diode shaping circuit. The resistance and diode combination shaping circuit will generate a sinusoidal waveform by taking the triangular waveform as an input. So the output of the resistance diode shaping circuit is the sinusoidal output, like this signal. So this output signal we are giving to an output amplifier. This output amplifier amplifies this sinusoidal information and it will give the perfect sinusoidal output voltage at the output part. So in this way we are generating three output signals. We are generating three functions from this function generator. Let us see the upper constant current source working and lower constant current source working and how this triangular wave is generating at this integrator part. Alright. So first coming to the basically, a function generator produces different waveforms with adjustable frequency. So it will generate the different types of output signals like a square wave, sine wave and triangular wave with adjusting parameters, and the frequency may be adjusted from a fraction of hertz to several kilohertz, several hundreds of kilohertz. So here we have up to nearly 1 megahertz or 2 megahertz, 3 megahertz or 5 megahertz. Different types of function generators are available in the market. Up to 5 megahertz function generators also available in the market. Presently, the 1 megahertz function generator cost in the market is nearly 5K2, that is 5,000 rupees to 8,000 rupees. And the 5 megahertz function generator, nearly it is a cost of 22,000 to 28,000 rupees cost. Now, the various outputs of the generators can be made available at the same time. So in some of the function generator, 3 output signals, square, rectangular and triangular, both 3 waves are available parallelly. So you can use any one of the output signal here. Otherwise we have some function switch. So sinusoidal, triangular, square function switches are generally available in the function generator. By pushing that, otherwise by selecting that button switch, you can select which function you require. And most of the function generators are coming with the phase lock operation, where the capability of the phase lock operation, it is nothing but as the function generator can be phase locked to an external source. That means here we are using 2 function generators. So the one function generator is controlling another function generator. Like one function generator can be used to lock second function generator. The first function generator can be used to lock the second function generator, and the 2 output signals can be displayed in the in phase by adjustable amount. By some phase adjustment, we can see both output signals at the CRO. Now, usually the frequency is controlled by varying the capacitor in the LC or RC circuit. In the frequency control network, by using LC circuit, otherwise by using RC circuit, we can vary the frequency of the oscillator. In this instrument, the frequency is controlled by varying the magnitude of magnitude of current which drives the integrator. In this function generator, we are controlling this frequency values by adjusting the upper constant current source and lower constant current source. The magnitudes of the upper constant current source and lower constant current sources, by adjusting these 2 parameters, we can control the frequency values. I said that previously we will get an output signal in the triangular waveform at the integrator. So the output of the integrator, we are getting a triangular wave. Here we are getting a triangular wave, right? So generally the integrator will give the output linearly, either increment value or decrement value based on the upper constant and lower constant current sources predefined values. Okay, right. The instrument provides sine wave, triangular wave and square waves with a frequency range of 0.01 Hz to 100 kHz. The frequency controlled voltage regulates 2 current sources. The frequency control network is driving 2 current sources. One is upper constant current source, second one is lower constant current source. The upper constant current source supplies constant current to integrator. So the upper constant current source, which will available at this place, this will give the constant current to the integrator. Okay, so the if it is sending the positive current, the lower constant current source gives the reverse current, which is passing from the upper constant current source. That means the upper current source is opposite to the lower constant current source. The upper constant current source supplies a constant current to the integrator, whose output voltages increases linearly. So whatever the current you are giving with that current, the integrator output linearly is going to be increasing with the time. According to the equation of the output signal voltage, that is E out is equal to minus 1 by C integral 0 to T I dt. So this is the energy output signal of output voltage which is generating from the integrator. Next, Now coming to that, an increase or decrease in the current, an increase or decrease in the current increases or decreases the slope of the voltages and hence controls the frequency. So the increase in the current at the upper constant current source or in the lower constant current source, these two will control, based on these two controls we can get the adjustable frequency based on our requirement. The voltage comparator multivibrator changes states at predetermined maximum level of the integrator output voltage. The states of the upper constant current source to lower constant current source or lower constant current source to upper constant current source, these two will change based on the selection of the based on the voltage comparator of this multivibrator. That is, actually this voltage comparator here we are using as a multivibrator. This multivibrator, it will collect the integrator output and it will send to the output amplifier. So before that we have to discuss one more point about lower constant current source. Right, this is a lower constant current. The lower constant current source supplies a reverse current to the integrator and the output goes to the decreases linearly with the time. So upper constant current source is passing some current. Due to that current, the integrator output is linearly increasing. Okay, with the help of lower constant current source, whichever the current we are giving, with this current, the integrator output voltage is continuously decreasing, linearly decreasing with the time. When the output reaches to a predetermined minimum level, so when the voltage is going to be decreasing, when it is coming to a predetermined minimum level, then the voltage comparator again changes the state and switches on to the upper constant current source. When it is reaches to the predefined level, automatically upper constant current source is going to be switched on, and thus upper constant current source is driving some current to the integrator, and now the integrator output is continuously going to be increased. So when it is going to be increasing, so for a set of predefined maximum level of the voltage, when it is reaching, automatically it switches the lower constant current source. Like that we will get the increment, linearly increment line and a linearly decrement line. Like that we will get a triangular wave signal. So the linearly increment curve and linearly decrement line, linearly increment, linearly decrement. This type of waveform we will get at the output of the integrator with the help of upper constant current source and lower constant current source. Next, the output of the integrator is we are calling as triangular waveform, whose frequency is determined by the magnitude of the current supplied at the constant current sources. The comparator output delivers a square wave voltage of the same frequency, and the resistance diode network alters the slope of the triangular wave as its amplitude changes and produces a sine wave with less than 1% distortion. Here the voltage comparator, detects this triangular wave and it delivers the same output with different frequencies in the square wave form, in the square wave shape. In the square wave type, the resistance diode network, it converts this triangular wave into the sinusoidal waveform. Okay, right. So this is about the function generator. Okay, so the function generator basically we are using in the research laboratories or service benches or in the educational institutions for laboratory purposes. With the help of this function generators, we are operating different types of electronic circuits. Generally in the laboratories, for example, coming to that UG level, we have PDC laboratory, pulse and digital circuit laboratory, ECA laboratory, electronic circuit analysis laboratory. In these laboratories, for checking all the circuits performances or the amplifiers, whichever the circuits can we have as per the academic regulations, these circuits has to be run with some signal generators. So for that reason we are using some signal generators with a range of 0 to 1 megahertz in the educational institutions. And these function generators are providing three outputs like this function generator: sinusoidal waveform, square waveform, triangular waveform. These three waveforms we can get from these function generators. Okay, thank you.